All right, section 3.5, operations on functions. We are going to be talking about products, and quotients of functions. Okay. So the previous videos we talked about the sum and difference of functions. Now we're going to look at the product and quotient of functions, and of course find their domains. All right. So the definition for sum and difference, or product and quotient. Product means multiplication. Okay. And it's also, it can be written like this. And sometimes you'll notice in some books they don't even put a dot in between. So sometimes this is the definition for products. Definition for quotient, well, that's your division. Now these functions here are interchangeable. I can do g of f, g of x times f of x. I can put g of x over f of x. These are interchangeable. So whatever, how they write it, like this or like this, will determine how you set it up. All right, so we're going to do a couple examples, and also we're going to find the domains as well. So let's look. Let's say f of x is equal to square root of 3x. And g of x is equal to the square root of x squared minus 1. All right. If you notice here, there's radicals with variables inside, so there's going to be restrictions in my domain. Okay. Now, if I apply it to a quotient problem, it creates another restriction. All right. So there will be multiple restrictions when we do quotient. Well, first of all, we're going to just work with, let's do a product. So let's do gf of x. In other words, I'm going to do g of x times f of x. So I'm going to do the square root of x squared minus 1 times the square root of 3x. Well, since we are working with radicals, since they both are in radicals, that means I can actually multiply the insides together. So I get 3x times x squared minus 1. And if I distribute, it gives you 3x cubed minus 3x. Now, since we have to find the domain, I would leave this here because it's been factored for you. That makes finding the domain a lot easier than if you start from here, because you got to go from here back to this in order to find the domain. All right. We know in this domain right here, we have 3x, x squared minus 1. This whole thing has to be greater than or equal to 0, because inside the radical cannot be negative. All right. So what we're going to do is we are going to, first of all, we're going to do a number line. All right. Well, first of all, there's two parts here. Here we have a linear part. All right. So that means I can take 3x greater than or equal to 0, and I can just go ahead and solve for x. All right. So there's part of my domain on that one. This part is a quadratic. If you remember the first video, 3.5, on the sums and difference, we did one with a quadratic and all that work. Well, we're going to do it again. So here, you got to take x squared minus 1, set equal to 0, find out what x is equal to. And you get x is equal to plus and minus 1. You got to do a number line, 1 and 1. I do a test point, put 0 in. So now, I'm going to go back to here, x squared minus 1 has to be greater than or equal to 0. So I'm going to use this. 0, so that gives me negative 1. Negative 1 greater than or equal to 0. That is false. So that means anything in between will not work. So that means it has to be the extremes. So now I got two types of domains going on here. I gotta combine the two because I gotta make sure both of these parts are true at the same time. So now what will be my interval that will make both of these true? All right, so I'm gonna take this and I'm gonna apply it to the number line. So here's 0. It's greater than, so that goes this way. So now I got both my domains put onto the same number line. So now I am going to find the overlap. All right. So the overlap starts here and it goes on this way. All right, because anything over here will make the red and the blue, will make both of these parts true. Okay. So now I can write it as the domain is x is greater than or equal to 1. Or in interval notation, it would be bracket 1 to positive infinity parenthesis. All right, so that's multiplication. All right, so now let's look at division. Actually, let me stop there. And on the next video, we are going to do the quotient. Oh, by the way, this is recorded in front of a live studio audience.